Welcome to this SC24 OpenMP Boost Talk. My name is Joachim Jenke and I'm working at the RWTH Aachen University in Germany. I worked on Archer for 10 years now, and I want to take this chance to present you the history of Archer, which is a data race detection tool for OpenMP. All started with a summer internship in Livermore. During this internship, I was working on the first implementation of Archer. This implementation was done by inserting threat sanitizer annotations in libopenmp. In this year, Intel just open sourced its OpenMP runtime and included it into LLVM. So we had the chance to look into the source code and add the threat sanitizer annotations. By default, TSAN support was off because of performance concerns. To use the threat sanitizer annotated runtime, you had to explicitly configure it with this CMake flag to turn the support on. In the same summer, another intern worked on a complementary compiler path that would whitelist race-free pieces of the code and avoid threat sanitizer instrumentation for this race-free code, which would result in performance improvements. This work was presented in a paper at the first LLVM at Supercomputing Workshop in 2014. In the lower right, you can see a sketch how a barrier would be instrumented in this implementation. We explicitly instrumented happens before annotations for all release and wait constructs inside of the OpenMP runtime, rather than describing semantic happens before as represented by an OpenMP barrier. The code was made available in a separate GitHub repository as part of this paper presentation. We also tried to submit a student poster at Supercomputing, but it was rejected because we only showed the correctness results, but did not show performance numbers. In September 2015, we started the upstreaming endeavor and submitted a patch for libomp in Fabricator, which is the code review framework for LLVM. Because of some discussion about the licensing, the program stalled and we need to figure out the licensing. In the same year, the OpenMP fall meeting was in Aachen. During this OpenMP meeting, we started some discussions about OMPT and how we can make sure that OMPT also works for correctness analysis like we would need it in Archer. In May 16, we presented an IPDPS paper about the static analysis work that we continued to work on and finished in these 2 years. For June 16, I found the first commit on the OMPT-based Archer tool. In October 16, we finally pushed the patch for libomp so that Archer was now available since the LLVM4 release. But still, it was disabled by default. From about that time on, you could also find a flag in the spec package to build LLVM that would enable Archer support. In 2017, the first version of the OMPT-based Archer tool was pushed to a public Prunus repository on GitHub. In the same year, we presented at IVOM a paper where we argued that the synchronization semantics that we can derive from OMPT events are sufficient to do the data race detection in Archer. On the lower right, you can see a graphic that showcases problematic scenarios where one thread leaves the first barrier quite late, even before other threads already arrive in the next barrier, and without special care, the tool would interpret false happens before relations. But in the paper we also show how we can fix that. In 2018, in April, we submitted a patch in Fabricator for review for the new OpenMP-based Archer tool. And in December, we received first comments for this patch. In March, we realized, okay, the world moved forward. OpenMP was finally ratified, and we had to update OpenMP for the final version as of OpenMP 5.0. And we also had to make the tool compatible with this new OpenMP implementation. So in March, we can see several updates for this merge request. In November, we finally got the tool accepted and the OpenMP-based Archer tool landed in LVM. This is a great milestone in the development of Archer because now Archer was active by default as long as the application was built with TSON, of course. If the application is not built with TSON, so if you don't want to do data race detection, then Archer is silently off. So no performance concerns from that side. The tool is now available since LVM 10, and if you have any new LVM installed, you will have Archer available. In the following year, we updated the implementation of Archer, and all the development was done inside of the LVM project. So one thing is OpenMP introduced detached tasks, and we immediately implemented the OpenMP support and the Archer support for detached tasks. Another new option allows you to ignore sequential code. This helps if you have a longer serial initialization in the program and still want to detect data races after this serial initialization. Without this optimization, you would increase the serial initialization time by even 10 times and then would have to wait for the results from the parallel execution. We also fixed the handling of task dependencies for non-sibling tasks. Up to this point, Archer would analyze dependencies as if they would be global and work even for ancestor tasks. In March 2021, we finally removed the initial implementation of Archer done with these thread sanitizer annotations in libOMP because they were off all the time and they are basically replaced by the new OpenMP-based Archer tool. In the same summer, I defended my PhD thesis where Archer was a significant part of the thesis. In 2023, we added support for new task dependencies, like for the OMP all memory task dependence and also for task wait with depend clause. In fall, we also developed a new task-centric analysis where the patch is still under review, now as a GitHub pull request. And as you can see in the lower table, the task-aware analysis or the task-centric analysis significantly improves the accuracy and also the recall of the tool, because for certain tasking codes, we can now detect the data race where the thread-centric analysis will miss the data race. What is the status today? Since Archer is implemented in LVM and integrated in LVM, it's basically available with all Clang-based compilers, as long as the vendors decide to include the tool into their build and release. Since this year, Intel seems to shift towards sanitizers. They announced deprecation of the Intel Inspector, and it will also be discontinued next year. And starting from this year, Archer is available, and in the latest Intel compiler version, Archer is also on by default. Cray compiler supports Archer in their toolchain, and also the AMD compiler package includes Archer. Several patches are still under review, For example, we have a patch which enables AVX512 support in Thread Sanitizer. At the moment, if you compile vectorized code with these wide vector instructions, data races will be missed. If you want to read further, I included several links for Archer documentation here, also a tutorial how to use the different sanitizers with HPC codes, and a list of all the Archer papers. I also want to use this opportunity to thank all the mentors, contributors and sponsors that helped to improve Archer over the years. With that, I thank you for the attention and look forward to meet you at the OpenMP booth.